Good morning, class. I am by name Mr. SANI. So I'm here standing before you at this hour of time to deliver a lecture on the topic application of differentiation. So we know the differentiation is the rate of change. So we are now going to see the applications of it in some area, particularly to the elementary geometry. So the area we are going to cover is the maximum and minimum, the point of inflection, velocity and acceleration, rate of change of physical quantity, and marginal cost of production and profit. So we begin with the introductions of the differential calculus. So differential calculus is applied in many areas such as science and technologies, engineering, economics, etc., wherever the rate of change are involved. It is usually possible to apply differential calculus to solve problems where there is rate of change. So we start with the maximum and minimum point. By definition, a point on a curve at which the dy dx equal to 0 is called a stationary point. At such point, the tangent is parallel to the x-axis. So to distinguish between the maximum and minimum, the values of x when the dy dx equal to 0 will be substituted in the result of 10 for the d square y all over the ds squared, that is the second derivatives. And those given with negative value of that, the second derivative will give a maximum value of the function. And those with positive will give the minimum value of the function. So take for instance, given example 1, find the maximum or the minimum value of the function y equals to 2x squared minus 6x plus 2. So as we mentioned earlier, we said we first of all stand what? Differentiate that particular function given. We know the differentiation is a rate of change of a particular function with respect to another. So y is going to be changed with respect to what? To the x. So given the function s as a y equals to 2x squared minus 4 minus 6x plus 2. So for us now to obtain the maximum or the minimum value of that particular function, we differentiate the given function. So as you can see where the cursor is touching, the dy dx now is given 4x minus 6, meaning when we differentiate this function, then we have this. So at the turning point, the dy all over the ds equal to 0. So after you differentiate that, then it means you equate that particular what you have differentiated to 0 and solve for x. So we equate this one onto x, we solve, then you're able to get the value of x equals to 1.5. So the turning point occur at the value of x equal to 1.5. So we now suppose we differentiate that particular function, second derivatives. That is, when we differentiate this again, we have the d square y all over the dx square equals to 4. So since the second derivative gives a constant number which is independent of x, therefore the second derivative dx as the dy all over the dx now is always positive. Hence, the given function is minimum when the x now equals to 1.5. So it then means the second derivatives as it giving the result 4, and the 4 now is depending on another value of x, or maybe it is depending on the value of x. Then we have to substitute the result of the x at the turning point into to determine whether it is a positive value or a negative value. That will account it to be either minimum or the maximum. So since it's a constant number and the result is positive, account to be what? Minimum. So therefore the minimum value of the function and x now given. You will substitute that value of x into the original equation given. Y equals to 2x squared minus 6x plus 2. So when we substitute that and simplify now, our result now is the minus 0.1 as a minus 1.5. Account the minimum value of the given function to that particular example. So the second example now is given that we should find the turning point on the curve of y equals to 2x to the power of 3 minus 9x to the power of 2 plus 12x, and distinguish between the maximum and the minimum values. So if we are now to do that, so we know that the function is given as this y equals to the 2x cubed, that is to the power of 3 minus 9x to the power of 2 plus 12x. So you will first of all now differentiate y with respect to x. So when you do that now, we have this result. So differentiate 2x to the power of 3, we have 6x squared. Differentiating minus 9x to the power of 2, we have the 18x. Differentiating 12x, we have 12. So for turning point now that's defined to be the first derivative equal to 0, then we equate the result when we differentiate equal to 0 and solve for x. So we equate this to x as into 0, then we find the value of x. So as you can see now they give you quadratic equations. So we solve this particular equation quadratically. So when we use the factorization method, we think of two values. When you add them together, you get the coefficients of x. When you multiply them together, now they give us the constant number. So we use the 2 and 1. So when we substitute and solve that quadratically by factorization method, we now get the result to be x equals to 1 or x equals to 2. So it means that the turning point exists with two values because of what? The equation will be resolved to what? Quadratic equations. We always have two results. So our value of x9 is equal to 1 or equal to 2. So to distinguish between them, we determine by finding the second derivative of the function as we differentiated it earlier. So when you redifferentiate that for the second time, now we have this result. So at this point, then if our s is equals to 1, we substitute in to replace the value of x, we have the result to be minus 6. So since the result is negative, it defines that it is a maximum point. That is, the maximum point now exists when the x naught is equal to 1. So you will also now substitute the second value of the x equal to 2 to that particular function in order to determine whether it is maximum or a minimum at that when the x is equal to 2. So as you can see now, if the x is equal to 2 substituted in now, our result now is what? Positive 6. So at this point, a minimum point exists. So the curve of a given function has a maximum when the point x is 1, and it is minimum when s is equal to 2. So for us now to have the maximum and the minimum value of the function, so the maximum value of the function at x equal to 1 is given us, you substitute it to the original function given in order to determine the maximum value. So when we substitute this and simplify now, the result is 5. Then also to find the minimum value of that function, we know that the minimum occurred when the s is at equals to 2. So substitute it to the original, we simplify now, we have this. So the maximum value of the function is defined to be 5 when s is equals to 1. And the minimum value is 4 when s is equals to 2. So the further example given, that is example 3, find the minimum value of x squared minus 3x plus 2 for all real value of x. So this now serves as the given function that we are now going to use. So to get the solution of that, we'll let y equal to that function, as you can see here now, where the cursor is pointing. So you will differentiate it for the first time. So when you differentiate this function, now we have this, that is why the y dx. So y is changing with respect to the what? To the x. So when you first of all differentiate it, then the turning point now occur at that particular point of the differentiation, and that equal to 0. So as you differentiate the function, you let that particular what you have been differentiated equal to 0, and simplifying to get the value of x in order to determine your minimum or the maximum point. So we substitute the value of that. When we solve for the x now, we have our x now is equal to 3 all over 2. You keep the result. So you will differentiate the function you differentiated already, that is the second derivative. When you take that, we differentiate now, that they give us a constant value 2, which is positive. And so the function has a minimum at the point of x equals to 3 all over 2. So for us now to get a minimum values, you will take that where the s equals to this 3 all over 2, now substitute it into the original given equations. So I'm simplifying, and finally now you get the value where it is what? Minimum. So the major thing for us now to understand when it is maximum or the minimum point is when you take the second derivatives of a given function. If it is a constant number and that number seeks to be positive, is minimum. When it is negative, is maximum. But when it is not independent of the x, and maybe now is given 4x, so you have to substitute the result of the x at that turning point when you find. When you substitute and simplify to what? To know whether it is positive or negative, that will account it to be a maximum or a minimum. So the point of inflection. So the point of inflection now we see that in this way. The stationary point where the curve has neither a maximum nor a minimum value is called a stationary. It is called a point of inflection. That is no turning point. Or it is a point on the curve at which the direction of bending change, that is from right hand to the left hand and vice versa. So that could be done when you are to find the point of inflection. There are 3 steps involved. The first step now says you have to differentiate the given function y twice. That is, when you take the first derivative, then you will differentiate that for the second derivatives. So when you differentiate it for the second derivative, then you solve that equation after you differentiate it twice and equal it to 0 and simplifying. Then the third step now you take to see whether or not a change of sign occurs in that second derivative via the value of x or not. So since we mentioned earlier that the differentiation is the rate of change of a given quantity with respect to another, so we can apply it to the rate of changing, that is the one involved the velocity and acceleration, since it has to do with the changing. So velocity defined as the rate of change of the distance with respect to time. So suppose that the distance x meter after t second covered by a moving object is given by, so at this point now you look onto that and solve. So let's take for instance, suppose that the distance d meter followed by a stone in time t second is given by the equation this. That is a stone now falling from the walls from above. So the distance when that particular stone is falling and at a time t defined to be this, d equals to 5t squared, then calculate its speed when t equals to 3 seconds. So to get the solution of that now, we know that the speed now equals to rate of change of distance with time. So the speed is x, and that will be equal to what? To d. So when you differentiate that d, that is the d prime now equals to the d of that t of, as a 5t of 2. So when you differentiate this function, we now have 10t. And when t is 3, that is 3 seconds, you substitute the value of t into that. You have this, that is defining the speed equal to the 30 meter per second. So it's the rate of change of the distance with the time. So applications of this, or the differential now, they apply to that because it's what it has to do with the changing. So you differentiate that particular function with respect to the time. Now the acceleration. So this is the rate of change of velocity with time. Hence, if the velocity of the object is v meter per second after t second, then the acceleration at any point or any time is given by the dv all over the dt. Remember we mentioned earlier that velocity is the rate of change of the distance with time. Then by the definition of acceleration is the rate of change of the velocity with time. So if you are being given a question on velocity, you differentiate that particular function given with respect to what? To the time. But if you are asked to find the acceleration, then if the question is in distance, you differentiate that to velocity, then you redifferentiate the velocity to get the acceleration. Now let's see. We said the acceleration now is the rate of change of velocity with time. Hence, if the velocity of an object is v meter per second, after t seconds, then the acceleration at any time is given by the dv all over dt. Now, suppose an object is moving such that its velocity in terms of t is given by this particular equation, meaning v now equals to 5t minus t squared. So the acceleration at any time is given by the dv all over the dt, and dv all over the dt is the gradient function of the graph when t is equals to 2. The acceleration of the object dv all over dt now is given as this. That is, we differentiate v with respect to t. So when you differentiate this particular function now, we have 5 minus 2t. Hence, at t equals to 2, you substitute the value of t and you get this. So it means the acceleration of that particular object when he moves in the velocity of this, giving us 1. I believe you understand that now. So you differentiate the given velocity with respect to time to get the acceleration. So another example is given as this. After t seconds, an object has traveled a distance x meter, where x defined to be equals to minus 27t plus 15t squared minus 3 cubed as a t cube, and now you are asked to calculate a, when its velocity would be 0, b, when its acceleration will be 0, and c, its velocity and acceleration after 10 seconds. So you can see now we start with the first one. So when the velocity is 0, then we have this. So you differentiate that function first and give us this. Then you have to equate that to 0 and solve for t. So at this point now, it gives us a quadratic equation. Then you solve that, simplifying it quadratically in order to get your what? Your t. So when you do that now, as you can see now, we have t equals to 1 and t equals to 9. Hence, the value of the velocity is 0 after 1 second and after 9 seconds. Now, when acceleration is 0, it means for that particular function, you differentiate it to get the velocity one time. When this acceleration is 0, you find that. Then for acceleration, now you have to redifferentiate that the velocity. That is the second derivative to give acceleration. So when you do that, now we have this 30 minus 60 and equal to 0. So that is when the t is 5, then substitute that now and simplifying, you have our result to be that. So the further example now is, that is example 6. The area of a cycle is increasing at the rate of 3 centimeter square per second. Find the rate of increase of the circumference when the radius is 2 centimeters. So since we say that the differentiation is the rate of change, so for a cycle to be increasing at the rate of 3 centimeters square per second, so you are asked to find the rate of increase of the circumference. So the circumference will increase when the radius is increasing. When the radius is increased, definitely the area of that particular the cycle will also increase. So the area will increase when the radius increase. The radius will increase also when the what? As in the circumference will increase when the radius is also increased. So it's the rate of change. So this one on account to be a function of function. Now let's see. The rate of change of area A of a cycle, that is the dA all over dt now, is equals to 3 centimeters square per second. So it's from the given example that we say the area of a cycle is increasing at the rate of 3 meters per second. So the dA all over the dt now will be equals to 3 centimeters square per second. So rate of increase of the circumference C of a cycle is now giving us to be what? The dt, as in dc all over the dt. So we cannot get that directly because of what? It has to do with the rate of change of the radius. So when the radius has been changed, definitely the circumference will also change. So when it increases, the radius increases, then the circumference also increase. So at this point now, we can do to find out of the increase of the circumference, will apply the rule of the function of function. That is function of function of the differentiation, as you earlier learned of that. So this now will give us by this formula, the dc all over the dt equals to the dc all over dr, multiplying the dr all over the world, the dt. So the dc all over dr now can be determined from the area of what? The circumference. So the area of the circumference is given by c equals to 2 per r. So when we take the derivative of that, the area of the circumference, we have this. So it now remains to find the dr all over the dt. So to do this, we differentiate the area of a cycle given by A equals to per r squared as before. So that is using the dA all over the dt will be equal to the dA all over the dr multiplied by dr all over the dt. So what we are looking for here then is dr all over the dt. Already we have the value of what? The dt as a dA all over the dt, and also we have gotten this dA all over the dr. So our dA all over dt is given to be 3 centimeter square per second. Why this of dA all over the dr? Now we have gotten that from the area of the circumference. So what we left for us now is the dr all over the t. So at this point, you divide the both sides by the dA all over the dr. Then we have this. So from there now we determine the value of the dr all over the dt to see when the radius increase. So our dA all over dt, we have x to be 3 centimeter. So our dA all over dr naught is given to be this 2 per r when we differentiate that of the area of the circumference. So we have the result to be this for the dt as the dr all over the dt equals to the 2 as in 3 all over the 2 per r centimeter per second. So if r is equals to 2 centimeter, then our dr all over the t now equals to 3 all over 4 per centimeter meter per square. So putting equation 3.2 and 3.1 into equation 3.1, and we have this. So another example now is given to be, given that y equal to 3t cubed plus 2t squared minus 7t plus 3. Find dy dt at t equals to minus 1. So it means given the function x, for us now to find dy, that is the rate of change of y with respect to this t. So we differentiate that function to have this. So after differentiate it, when t is equal to minus 1, you substitute in, and we obtain this value to minus 2. So you are asked to find what? The dy all over the dt, that is the rate of change of this particular given function. So the example 8, find the gradient of the curve y equals to 2 square root of x minus 1 all over x at a point s equals to 1. So in this case now, the given function, we have to rewrite this given function to this before you take your derivative. That is, you differentiate y with respect to this x. So when you take the derivative, dy dx now equals to, we have this. That is, the power 1 over 2 is coming to multiply 2. Then minusing, the power is minusing by 1 to have this. And also goes to this. We have this. So after differentiating them, then you rewrite them back to their own amount as it given from the original equations. That is, our dy all over ds now will be given to 1 all over the square root of x plus 1 all over s squared. So when s is equals to 1, you substitute in, and simplifying, and we have our result to be 2. So we have now getting the result of what? Find the gradient of that. That is the rate of changing. So the next thing is marginal cost of production and profit. So the quantity of products produced by a company can be used to analyze the cost of production for the company. So in this case, is the rate of changing of a thing. The differentiation is also what applied to that. So let's see this example that it goes to that. If the cost of manufacturing X item is given by C of S equals to S cubed plus 20x squared plus 100x plus 10, find the marginal cost function. and compared the marginal cost at x equals to 50 and the actual cost of the manufacturing the 15 item. So to get the result of that, to obtain the marginal cost, we differentiate the cost function. That is, given this function and we differentiate it. When we do that, we have this. Then the marginal cost at x equals to 50. After differentiating, then you substitute the value of x when x is equals to what? 50. So you substitute this into and simplify. So when you simplify that now, it gives us the result 9,600. Then we now say the cost of manufacturing the 15 item is C of 50 minus the C of 49. So that x, this one minus this. Whatever you 16 and you substitute that, the value of x to be 15 and the value of x to be 49, simplifying them. At the end of the day, we have our result to be 9,406.31. Hence, the actual cost of production or producing the 15 item is given us to be this. Now, the next example now you have to find the maximum profit. R of x now equals to 10x minus 0.002x squared naira, and C of x equals to 2x plus 1,000. You have to find the maximum profit of it. So the profit equals to the revenue minus the cost of production. So already now the revenues now is giving us to be this, which defined to be the R of x, this. Then minus the cost of production, giving us to be this, C of x equals to 2x plus 1,000. So when you simplify that, by collecting the lighted, we have the profits defined to be this. But for us now to find it to be a maximum profit, we know in the maximum point or a minimum point earlier when we discussed, you differentiate that function and equate that to 0 and simplify for value of the x. So that same idea now we come into this. Our profit is P equals to 8x minus 0.002x squared minus 1,000. So when you differentiate this function now, we have this. So at the turning point now, we know that the dp all over the days are equals to 0. What we are differentiating to that of the p now, you equate it to 0 and simplifying for x. So when you're simplifying, you get our x now equals to this. Then for us to know whether it is maximum or a minimum, you will differentiate for the second time to determine whether the result is negative or the positive. So in this case now, where we have that first derivative, we differentiate that again now to have a second derivative, giving us to be the minus 4 as the minus 0.004, which is less than 0, indicating a maximum point. That is, the value is minimum as in negative, then it is a maximum point. So the maximum profit now x, giving us to be this. So when you simplify now, we have 7,000. Account to be the maximum profit. Now, so with this particular what we have discussed since, I believe you will have an idea on the application of the differentiation So we can use that to apply to the kind of question given if rates of change involved. So I believe you are clear with what we have discussed earlier. So here are the exercises for you now to go and practice on. Use the law, the same ideology or the law, the understanding of what we have done in the class now to attain to these exercises given. So the exercise number 1 and is given to be this, like that now to exercise 10. So go and practice them accordingly. So at this very point now, we call it a day. Or if there is any question that you ask, place your questions for answering. Thanks.